Okay, this is the second part of geometric sequences and series, so make sure you watch part 1 first. So a lot of the definitions that we want to make here are very similar to the ones that we used with arithmetic. We just defined sequences, now we're looking at series. Series is just a sum of terms of a sequence. So if we had 4, 8, 16, 32 as our geometric series, which is where we're multiplying by 2, then the series that goes with that is 4 plus 8 plus 16 plus 32, etc. Now, if we just think about those four terms together, that would be a case where A equals 4, where R equals 2, and where N equals 4, because there are four separate terms there. We use Sn to stand for the sum of these n terms. So in this case, we can say that S4 is equal to 4 plus 8 plus 16 plus 32, which is 60. And then we have this formula. Now we're going to prove this in a couple of pages' time. But we're just going to see how that it does work to start with. So in this case, if we wanted to work out S4, and we should be getting that answer of 60 that we worked out earlier, we sub in A, so that's the first term, which was 4. We then do 1 minus 2, because that was our value of R, to the power of 4, all over 1 minus R, so all over 1 minus 2. If we then expand and simplify that, we'll get 4, lots of minus 15, over minus 1, which is 60. So yeah, that works out. Let's see how it actually fares though. Okay, so let's use this formula. You might want to pause this first and have a go before I go through them. I'm assuming you've done that now. So for our first sequence, we go 4, 6, 9. So that means A is equal to 4, R is equal to 1.5, that's 6 divided by 4, and our number of terms is 10. So we're trying to find out the sum of the series, so we want S10. That's going to be 4, lots of 1 minus 1.5 to the 10 over 1 minus R. And if we plug that in, we'll get that the sum of the first 10 terms here is 453.32, and it goes on for quite a while. For the second sequence, again, you can have negative ratios, don't forget that. We've got A is equal to 3. We've got R is equal to minus 2/3 in this case. You get that by doing minus 2 divided by 3, or 4/3 divided by minus 2. And N is again equal to 10. So we're again going to try and find S10. That's going to be 3, lots of 1 minus, and if you're raising a negative number to a power, make sure it's in a bracket, all over 1 minus 2/3. No point really simplifying that, so we'll just plug it all in, and you should get an answer of 1.768 ... Again, interesting that that is actually less than the number you start with, but it makes sense considering you're adding negative numbers to it straight away. Okay, let's do the inevitable introduction of logarithms. Here we've got a series which goes 2, 5, 12.5, etc. In this case, A is equal to 2, because that's what we start with, and R is equal to 2.5, because that's 5 divided by 2, and so on. And we want to find when the series exceeds 10,000. So we're saying, when is Sn greater than 10,000? Now, we have a formula for Sn, so the first thing we're going to do is plug that in. Instead of Sn, we're going to say we've got 2, lots of 1 minus 2.5 to the n over 1 minus 2.5, greater than 10,000. My first thing I might do here is divide by this 2. So if I do that, I'll end up with 1 minus 2.5 to the n over, and let's actually work this out, 1 minus 2.5 is minus 1.5, and I don't think I need these brackets anymore. That's greater than 5,000. Then I'm probably going to divide by the minus 1.5, but remember, if you do that with an inequality, if you divide by a negative, you've got to flip the sign around. So we'll end up with 1 minus 2.5 to the n is less than minus 10,000 over 3, or about minus 3,300. What would you do with that then? So one option would be to like times things by minus 1, but I prefer to swap things around. So I'm going to add the 2.5 to the n to that side and add the 10,000 over 3 to that side. So we'll end up with 10,003 over 3 is less than 2.5 to the n. And at this point, you essentially have yourself a logarithm question, or you could do this by the trial and error that we looked at on the previous question. Let's do logarithms this time. So I'm going to say that ln of 10,003 over 3 is less than ln of 2.5 to the n. Take the n down and then divide across by it. So I'll eventually end up with n has to be greater than ln of 10,003 over 3, all divided by ln of 2.5, which gives us that n has to be greater than 8.85 or thereabouts, so n must equal 9. Happens pretty quickly actually, doesn't it? Okay, so going a little bit in the wrong order, the last thing we're going to do is prove this theorem. And again, it's one of those nice sort of proofs. I'd really recommend you learn the steps for this. So in order, the first thing we need to do is write down the terms. So if we're saying that we're finding Sn, then what we're saying is we're doing A plus AR plus AR squared plus and so on, all the way up to AR to the n minus 1. That's our last term. In fact, let's actually include even one more term than that. We want to multiply this by r. That means both sides. So on the left-hand side, we're going to end up with rsn. And on the right-hand side, we're going to end up with ar plus ar squared plus ar cubed plus ... and our last two terms will be ar to the n minus 1 and ar to the n. Now the clever bit is we are going to subtract them. We're going to take away the bottom from the top, and we're going to end up with Sn minus Rsn. And then if we think about this subtraction, then we're going to do this AR, take away this AR. So they will both cancel out. We'll do AR squared, take away AR squared. And we'll repeat that with nearly every term. We'll have something. So we'll have AR to the n minus 1. That'll be taken away. This term will have something here that's taken it away. And the only terms that are left are your A and your AR to the n minus 1, to the n rather. So it's top take away bottom, so we'll end up with A minus AR to the n. Very powerful step that eliminates a potentially infinite number of terms and leaves you with 2. So I said for 4-step we need to factorize. So we're going to take out a factor of Sn on the left hand side, and we're going to take out a factor of A on the right hand side, and then we're going to divide. So if you look at what we're trying to make it look like, we're basically there. We just need to divide by that 1 minus r. And there you go, matching the formula. Very cool proof that.